every morning with drive. Being on the grind, know I had to survive. We had to win. Started from the dirt and the rubble. I had to be the needle that was popping your bubble.
Hello and welcome in, everybody. What's going on? I want to give you a quick update on some of the stuff I've been working on, trying to build a prospect model for running backs coming into the NFL. And as you have seen in the previous video, we got an RStudio data regression analysis type of model built. I have been spending the last couple of weeks fine-tuning version 1.0 essentially of my neural network. So machine learning, building a neural network, putting in 20 different inputs into the system, and then getting results spit out via our Python code that we have built. So just to give you a little look at what we have. So here's our data frame that we're using. We have 242 different running backs in here. And really the data set is any running back within the last 10 seasons, so 2013 through 2022, the last 10 seasons, any running back with at least 80 opportunities in a season, and their associated PPR Fantasy Points per game best season that they had with at least 80 opportunities. So going through, just putting in everyone's career best fantasy points per game that they achieved, and then having the inputs, weight, height, draft spot, BMI, hand sizes in there, their shuttle, cone drill, bench press, their Spark X score, their 40-yard dash, speed score, broad jump, agility score, burst score, vertical jump, breakout age, college yards per carry, their receiver rating that they had in college, along with their college dominator rating and their college target share. So 20 total inputs. We just say, hey, we have all these inputs. We're interested in what that player could give us in terms of fantasy points per game in a season for their career best. And really this is, if provided they get 80 opportunities in a season, this is, tell me what can we expect from this particular player. I do want to just give a brief overview, I guess, of the code and kind of what ChatGPT thinks of my particular code. So actually, before we get into this, let's maybe pop in and start running some of the code here to begin with. So in order to do that, we're going to open up one of our files called Independent Rookie. And really a good gauge of something that might happen is James Robinson, right? He came out of the middle of nowhere his rookie year and just absolutely dominated. I believe his rookie year was the best year he had, 17.89 fantasy points per game. So we're going to take all of these inputs from James Robinson. Hey, what kind of player would this guy have been? We're going to paste him into our individual rookie running back for 2023, and we'll just treat James Robinson as a prospect. Him into our model. So we'll get rid of the old file that was in there. We'll upload the new file that has James Robinson in there as our individual person, and then we're just going to tell this to run. So while that kind of runs in the background, I'm going to just list what ChatGPT said this particular script is doing. And really, it's almost, you can kind of think of it as 100 simulations that we're doing for this player's career. And provided they get 80 opportunities in a season, what can we expect for their career best fantasy points per game in PPR settings? So ChatGPT says this script loads a data set, performs some data pre-processing, trains a neural network and a random forest model, and makes predictions on a new data set. It also plots the feature importances of the random forest model and prints some summary statistics of the predictions. You can kind of see that on the code right now. We're printing the percentiles of these predictions, mean, medium, minimum, maximum predictions, standard deviations, and then what the 90th, 75th, 25th, and 10th percentile predictions were, as well as an M50 gap. So that M50 gap is actually the difference between the 75th and the 25th percentile, and that kind of tells us How sure is the model, that mid 50%, how tight is that range? If it's super wide, the model's giving kind of a lot of different predictions as far as what this person's career could look like. If it's pretty tight, something, in the 2 or less range for their fantasy points per game output in between their 25th and 75th, the model's kind of saying, hey, we're pretty sure, those mid 50 predictions, they're going to fall in this really tight range, and you can be a little bit almost more certain that that particular running back is going to fall within a range similar to that. So again, to ChatGPT, the script first loads the data set from a CSV file, which we already saw, that data frame on there with the 242 running backs. It then separates this data set into independent variables and a dependent variable, which is our fantasy points per game best in their career. Next, the script uses a k nearest neighbors imputer to impute the missing values for those inputs and scales the features using a standard scaler. So any particular prospect that actually goes into this model can have some missing data points here. So we see Patrick Laird, he's missing bench press and a SparkX score. Those two values, we can either treat them as just ignore, or we can use a k nearest neighbors imputer. So it's going to go through and it's going to find like the nearest neighbors based off of what his inputs are and what the expected bench press and SparkX scores may have been. So that's what this is doing. Any missing data is going to get filled in by what the algorithm figures are the nearest neighbors. So it uses like the 15 nearest neighbors and says, based off of those 15, what should this value likely be? And then it'll use that as the value for that particular player. The script then loops 100 times and splits the data into a training and testing set each time using a different random seed each time. For each split, it creates a neural network model with 4 dense layers and trains it on the training set using mean squared error loss and the Atom optimizer. It then evaluates the model on the testing set by computing the mean squared error and mean absolute error. After each evaluation, it uses the trained model to make a prediction on the new data set. So in this terms, it's what's currently going on to predict James Robinson. And we'll see what that comes out as at that point. But it evaluates the model on the testing set by computing the mean squared error and that mean absolute error, and then makes that prediction, like I said, on the new data set that is loaded from another CSV file, which we saw me upload before. The new data set is then pre-processed in the same way as the training data set, and the predicted value is appended to a list. So that list, every 100 times, it's going to get a new value into that list, and it's going to basically compile all of those. After the loop, the script fits a random forest regressor model with 250 trees to the entire training data set and computes the feature importances of the model. It then plots a horizontal bar chart of the feature importances with error bars showing the standard deviation of the importances across the trees. Finally, it computes and then prints the mean, median, standard deviation, minimum, and maximum predictions of the new data set. It says overall, the script performs several data pre-processing steps, trains and evaluates a neural network model, and then uses a random forest model to compute feature importances and make predictions on a new data set. So that's what ChatGPT says about the code. The random forest regressor, going through those 250 trees, what that is doing is actually spitting out 100 simulations, and it's taking that 100th simulation and it's going to say, hey, based off of what this training set was on the 100th time, what were the feature importances of that particular training set, and should be getting close here to finishing up here on the neural network. Again, this is model version 1. We're just saving the version 1 until we get completely finished here, but at the end, it's going to spit out what James Robinson's expected career best fantasy points per game should be. Again, here's the feature importances. So we see draft spot scaled, way more important than most anything else. Importance, you can kind of think of that as percentage based, 30-some, 40-some percent with the standard error bar. So pretty much no less than about 25, 26% and upwards of almost 40%. of the weights for that 100th prediction is based off of the draft spot. And every single one that I've ever done here, draft spot is always number one, right in that range between 25 to 45%. And then it's a mix between the college dominator rating, like you see here, as second, breakout age, speed score, college target share gets up there, receiver rating gets up there. This particular training set said, hey, the receiver rating isn't that important in this training set. College dominator rating was a little bit more. Breakout age seemed, the third most important. College yards per carry was actually fourth in this list. Sometimes that's further down in the 7 to 10 range. But again, we're doing 100 career simulations. We're getting a new training set each time and evaluating the test set on that training set and then creating predictions. So it's running 100 simulations for this player's career. Again, this is James Robinson, and this is what it's saying for mean predictor. So the average of every single prediction, 12.5 PPR points. The median outcome, 13.3 there. And if you think of this in terms of running back points per game, 13.3 is going to be like a low-end RB2. We have a minimum prediction here, 5.2, and a maximum prediction of 17.42. I believe he did have in real life maximum of 17.89. So he actually, on this particular 100 simulations, bested his maximum prediction. This is actually the first time I've sent through someone who actually beat their maximum prediction in the 100 simulations. So good for him. But really, I wanted to express that this neural network is doing something that would be very eye-opening, especially when you take into consideration, this is James Robinson and in Dynasty. So if we look at his output, this is just a visualization of what James Robinson's career best fantasy points in a game, per game in a season would be, and the outputs and how many kind of were in a particular range. We have that big gap there between the blue and the yellow line, which is the 25th percentile and 75th percentile. But really, this is saying we expect a lot of the outputs in this particular player to be in that like 13 plus range. That's a pretty solid amount that are up there. Half of them actually, above that 13.3 range if we take the median number there. So what that is telling us is, hey, this particular person is probably going to have a low-end RB2 season at some point in their career. James Robinson was somebody in 85% of rookie drafts. The year that he came out wasn't even getting drafted. So if people did draft him, it was, super late, 5th round, 6th round draft pick. But other than that, like a lot of them, he was going undrafted in those 5-round, 12-team leagues. Which is very surprising. This is why I kind of wanted to highlight what this neural network can do. A player like James Robinson, we plug him into this model, it says, hey, he's looking more like a low-end RB2 at some point in his career. That's somebody that you should be drafting at some point. Then you have to take the assessment, is this guy even being drafted? No, then you can wait till the 5th round. If this is somebody that's normally going in the 4th round, maybe you see, hey, he's going to give me an RB2 performance at some point. I'm going to make sure that I get him and take him, in the 3rd round, just to ensure that I actually get him on my squad. But highlighting what can be done with neural networks, I built this in about, a weekend, essentially, kind of going through Googling how to do all these things, and built this neural network out to produce these results. And this is another thing that I plan on doing for all of our prospects that are coming out. We're going to have the previous version, which is the RStudio version, what's going to give that prospect score of their fantasy points per game, and then, or what you can think of fantasy points per game as their prospect score. And then we'll also provide this neural network model within each individual prospect. So we'll have the RStudio model, we'll have this Python model, Python script model in there for you. Really, as you can see, as these feature importances, draft spot is by far and above the most important factor in a particular model's output for fantasy in the NFL. So pre-draft, it's almost useless to run these models without putting in a projected draft spot. And when that's the case, it's not going to be super accurate. may as well wait till the NFL draft to get some of these out. But at that point, I plan on cranking out some neural network stuff, plugging in all of the inputs for our incoming rookies and giving you those prospect scores and running them through the neural network to let you know what the machine learning process is telling you the output is for these particular players. I've already done some of this for some incoming with their stuff, so go on over to Twitter at Todzilla1337 and go look through my tweets. You can find several different prospects incoming, and then also other veteran prospects that have gone through this model and treated like they were incoming rookies, and seeing what their 100 career projections would be, or their 100 career simulations. So if you're interested in something like this, I think this is completely unique in the fantasy football industry. We don't have any machine learning models out there. It's a bunch of people doing data analysis and kind of parsing out, hey, if these two metrics kind of line up, their yards per team pass attempt and this other metric, this is kind of the pool of people that we can expect them. So this is really, going above and beyond that aspect and just saying, here's all the inputs, here's what the output for these particular players has been in their career. Tell me what this individual player should do. We're going to run 100 simulations, and we're going to give you the mean, median, the minimum prediction, the maximum prediction, what that standard deviation is for all of the predictions, and then the 90th percentile, 75th, 25th, and 10th percentile outcomes, as well as that M50 gap, which will tell you, the smaller the number is for that M50 gap, the model is more certain or of a narrower range being achieved by this particular prospect coming out. The larger the gap, the more unsure, the more further away some of those predictions may have been for that particular prospect. Anyway, I hope you enjoyed this video. Please consider subscribing if you're new here and want to see these running back prospect models. There is plans in the future to build out a wide receiver model, a tight end model, a quarterback model with, upwards of 20 or more inputs. Whatever I can kind of put my finger on, I'll have in the data frame for the machine learning model to learn. I already have the framework and code here. I just need to change what it's looking at and what the output is in terms of the headers on those columns, and it'll just spit out data for us, which will be pretty amazing. Anyway, just wanted to share that with you. It's going to be something that I'm also building a data frame for on the adjusted line play report. I have all the raw data that produces the rankings during my show. I just give you the rankings of what they are and pit each matchup against each other. Hey, this particular offensive line is really good. This particular defensive line is not very good. This quarterback's going to have a lot of time. Well, I have all that raw data stored. I'm going to utilize what I can of machine learning and what I know about that to produce maybe some more accurate data in terms of the adjusted line play report for the 2023 season. Excited to do that. I got 4-5 months basically to come up with the code, build the data frame out, and get this stuff up and running for the DFS shows. At the very least, it'll be as same and as good as it was last year. Super accurate. We had about 70-80% success rate there, and gaining money on a weekly basis. But yeah, good things to come here, folks. Thank you for watching. I really appreciate the time and any support, kind words that you have, comments of what you would like to see, prospects that you want to see. Hit me up on Twitter at Todzilla1337 and we'll get you squared away. Thanks for watching, everybody. Have a good one. Bye.
Yeah, whole crew on top, really we on top. Wake up every morning with drive. Been on the grind, know I had to survive. We had to win. Started from the dirt and the rubble. I had to be the needle that was popping your bubble.